All right, well, let's go ahead and look at the parts of the kidney, and then eventually let's look at a better in-depth view of the nephron. So we know that this is the renal vein, this is where blood goes into the heart, and you have this video game at the bottom of this module, so you can play it on your own. Um, Artery, this is where blood travels into the heart, into the kidney. Um, we're going to go ahead and use the kidney itself to kind of keep going. But if we keep going, you'll see that we have our kidney. And inside our kidney, we have just one nephron in this picture. But keep in mind, there's millions. We have our afferent, going to lead blood into the nephron. Then we have our afferent, and we're going to keep going. We'll have blood come in through our PTC, proximal distal tubule, and we're going to have the nephron sort of come and do that for us, and we'll finally have blood sort of take away any of the nutrients that we gathered from this material and dump it back into our blood, and we're going to leave through that. But let's go ahead and check out this video. So what's going to happen here is that we have different things that are going to pass through the renal capsule, and some things are going to go right into the blood, right back into the blood, either through the direct source or it's going to go through these capillaries later. We're going to have our proximal tubule, we have our loop of Henle, both sides, and then we have our distal tubule, and then eventually our ureter. So let's see what happens to urea. Urea is waste, right? So if we watch that, what's going to happen is it's definitely going to make it all the way outside of the nephron, and it's definitely going to collect out as waste. It's that yellowy, smelly material. If we go ahead, and let's think about our next thing that we want to use. Let's go ahead and just see what glucose does. Glucose, we're going to go ahead, and we want that, right? So what's going to happen is it's going to get dumped into the bloodstream, usually from our PTC, and it's just going to go back into our body. So when you're testing for somebody for kidney function, you are testing for glucose levels, because if you see glucose, you know something's up. Let's go ahead and do water. Water is going to come in, go through the PTC, dump right into the bloodstream, and go back, unless you have too much water in the system. Then you're going to push it through all of the ureter and move it down into the body. The body could potentially even notice later at the distal tubule that you need water back in, and that's where water could come back into the kidney, into the these capillaries, and dump right back into the heart, into the body, eventually to the heart. Proteins. Proteins don't even make it into the nephron. They're too big. Eventually, they're just going to go back to the heart. What about sodium? This one's interesting. Oops. Definitely goes in. It's super small. At the loop of Henle, what you'll see is it'll be actively transported out. Some will leave if you have too much salt in, but most of the time what happens is at the loop of Henle, it'll come out and sort of come over here. If we were to do the water one, you'd see that water would now come out here too. They'd both go into the bloodstream and go back. So let's do those two at the same time. You see salt's coming out. You can see water's coming out of a bunch of different places. And because salt came out over here, water is going to have a better chance of leaving now. And it's going to keep collecting and dump out this way. Because remember, salt and water comes in at the same time. But keep in mind, your body's actually doing this. Super confusing. So it's easier to think about one item at a time and where it's going. But you could see as some things are definitely going to keep getting dumped out of the body. Regardless, urea is always going to leave. But some things, depending on what hormones are telling us, are going to say, okay, no, we definitely need them back, or we definitely want them out. And we'll talk about why that happens soon. If we look at what our proximal tubule is doing, we're looking at here are the capillaries, here's the proximal tubule right here, and we're using different ways to get things out. So urea is the black dot, it's definitely going to keep going. Water is the blue, that one gets pushed out into the bloodstream. Glucose is orange, yellow, and that's going to get moved out. Proteins, I don't think we've seen any proteins. But proteins will get pumped back in, so we'll kind of look at that in a second and see how that works. You can see that we do have some sodium potassium pumps, and we'll talk about how they're going to be forced to move some things into the bloodstream, and that's going to be mostly sodiums because we need them for muscles. We're going to have some that are designed to get glucose into the bloodstream, and they're going to be using a facilitated diffusion to do that. And then, of course, we're going to have some that are designed for water. These are going to be called aquaporins, and they're just going to let water run right into the bloodstream, only one direction. The loop itself, how it works is, you'll remember that water is blue and sodium is that light blue color. So as sodium starts to collect here, what's going to happen is it's going to make a better efficiency for water to come out too. And because of that, water and salt sort of chase each other. We'll talk about that a little bit soon too. And then eventually things are going to go out to the ducts. So we're going to go out to either the capillaries or the ducts that are going to send things out as waste. But hormones will definitely affect this. So if the hormones are turned on, which is anti-diuretic, you'll see that we'll have another shot at getting the waters out, and we won't produce as much urine. But if we turn off ADH, you're going to see that we're going to be able to make that water go out to urine. So that's going to be one of the hormones that we're definitely going to talk about. On, dumping it into the capillaries, off, out as waste. Cool.